for 1 second, the Earth suddenly stops spinning? It sounds like a science fiction question, but it's one that helps us understand how delicately balanced our planet really is. Right now, the Earth spins at a speed of about 1,670 kilometers per hour at the equator. You don't feel it because everything around you, the air, oceans, and even you are moving at the same speed. But if the Earth stopped instantly, even for a second, everything not anchored to solid rock would keep moving at that same velocity. In that single second, the entire atmosphere, oceans, and everything loose on the surface would continue hurtling eastward. Cars, buildings, trees, and even entire cities would be thrown sideways at over 1,600 km per hour. It would feel as if a global scale explosion had taken place. The winds generated would flatten anything in their path. Coastal regions would experience tsunamis hundreds of meters high as oceans sloshed violently across continents. It's hard to imagine, but the destruction would make any natural disaster in recorded history look small in comparison. But one may ask, why is the Earth spinning at all? When the Earth formed around 4.5 billion years ago, it began spinning as leftover gas and dust coalesced under gravity. The law of conservation of angular momentum kept it rotating, just as a skater spins faster when pulling their arms in. There's no external force large enough to stop it abruptly. Even the friction caused by the moon's gravitational pull, which causes tides, only slows Earth rotation by about 1.7 milliseconds per century. So, the idea of it halting suddenly is purely hypothetical, but scientifically fascinating. And what happens right after? If the Earth somehow stopped spinning and remained still, day and night would cease to exist as we know them. One half of the Earth would face continuous sunlight, scorching hot, while the other half would be locked in endless darkness and freezing cold. The oceans would migrate towards the poles, submerging regions like Canada and Siberia while leaving equatorial areas dry. The magnetic field, which depends partly on the motion of molten iron in the core, would weaken or collapse, exposing life to harmful solar radiation. The atmosphere would realign slowly, but climate patterns could be completely altered. Permanent storms near the twilight zones, frozen deserts elsewhere. And if Earth's rotation slowed gradually instead of stopping instantly, life might have some time to adapt, but the effects would still be enormous. Days and nights would grow longer, perhaps lasting weeks or months. Plants and animals dependent on sunlight cycles would struggle to survive. Winds and ocean currents, which rely on the Coriolis effect, would change drastically, altering weather systems and rainfall patterns. The planet's shape, which is currently slightly flattened at the poles and bulged at the equator, would slowly become more spherical, changing sea levels and coastlines globally. Interestingly, this thought experiment tells us a lot about how fragile yet perfectly balanced our planet is. The spin of the Earth gives us day and night, regulates our temperature, drives the winds, and even helps sustain the magnetic field that shields us from cosmic radiation. Without it, life and even the very structure of the planet would look nothing like what we know. And why is this important for us? It reminds us that Earth's systems, rotation, revolution, atmosphere, magnetism, and climate are interconnected. Disturbing one affects the rest. So,